Alright, here we are in the second part of section 4.2. I just didn't want the videos to get overly long and allow you to break up the different parts. And so they're asking us to graph over 2 periods. 1 period's fine as well. As we look at something like E, we want to just kind of be prepared. So my suggestion is draw a base graph and then do the appropriate labeling. So some things that I look at first is if there's a height adjustment, and there's no phase shift for this. There is a drop down of 2. So what I'm going to do is come in here and I'm going to do what I've always modeled, and that is drawing the regular cosine function. So if I draw the regular cosine function, it's got a height though of 3. So remember, cosine starts at high, so we're going to go there and we're going to drop down to 0. Then we're going to drop all the way down to -3. Then we're going to turn around, come back to 0, come back up to +3, come down to 0, come down to -3, come up to 0, come up to +3, come down to 0, come down to -3. And it just keeps going forever, right? This one's going to come down to 0 and down to -3 there. So there's our regular cosine graph. It's not been flipped at all because of the +3, so I drew it the way that it should be. 2x. There's no phase shift at all, so this is definitely 0. We're not moving that x-axis. I'm sorry, we're not moving that y-axis at all. I think we'll end up moving the x-axis. So let's talk a little bit. What's this 2 going to do? That's going to adjust my period. My original period was 2 pi, meaning from this point to this point was 2 pi. Well, it's no longer 2 pi. It's 2 pi divided by 2. That means this is pi right here. And that this right here is 2 pi. And that right in the middle is pi over 2. And you can start to get some of these main pieces. Those are going to stay because we're doing no phase shifting whatsoever. So what's the -2 going to do? The -2, you know what it's going to do. It's going to drop this graph down 2. Well, if you drop the graph down 2, then essentially all you're doing is moving your x-axis up 2. That dropped it 2. So here is 0, 0. Let me get rid of the original 0, 0. Now let's make sure that this works. Let's plug in a 0. If we plug in a 0, we have this. Now remember, this is 1 now. This is 1, 2, 3, 4, 5. -5, right? So let's try something. What is f of 0? Well, it's -2 plus 3 times the cosine of 2 times 0. Well, the cosine of 2 times 0 is the cosine of 0. Sorry, not theta. Cosine of 0 is 1, times 3 is 3, minus 2 is 1. Perfectly placed. Let's look at pi over 2. -2 plus 3 times the cosine of 2 times pi over 2. Right? That would be f of pi over 2. What's that? That's -2 plus 3 times the cosine of pi. Now what's the cosine of pi? The cosine of pi is -1 times 3 is -3 minus 2 is the -5 that's there, and it's perfect. We didn't stress about making it super long. We just drew our base one and then moved where the 0 line was. Let's see if we can do that here as well. As we go to this next one, I'll try to be really careful. This is also a cosine one. So coming straight down here, and it can be tedious, but it also can be fun, so just try your best in there. We have, remember what I looked at first, my amplitude, 2/3. So instead of 1, it's up 2/3. And we're going to drop to 0 and then go down to 2/3. Come back up to 0 and then back up to 2/3, drop down to 0 and down to 2/3, up to 0, up to 2/3, down to 0, down to negative 2/3, back up to 0, down to 0, down to negative 2/3. And so we'll just say that that's negative 2/3. Well, actually, we don't label that yet because we're going to move that guy. Okay, so we're calling that 2/3. Now, what else is happening? 1/2 x, I get a period adjustment. What's my new period? My new period, well, my old period was 2 pi, now I'm going to divide it by half. My new period is going to be 4 pi, right? Because we're great with fractions and complex fractions. We need to be. So down, back up. So right here should have been 2 pi, but now it's 4 pi, which means right in the middle is 2 pi. And then if I come way out here, this right here is 8 pi, right? So I've got my two periods shown. In the middle is 5 pi. And not 5 pi, 6 pi is right in the middle. Sorry about that. 6 pi is right in the middle of that guy right there. So you can see some cool polar graphs that we're going to do in the end. So we're almost to this. It's a little bit of a pain. So what if I not take into account that we're being shifted up 1 unit? So what does that mean? That means this whole graph is being shifted up 1 unit. So it means I need to take my line and move it down 1 full unit. And be right here. Now let's check something out. Let's check out cosine. Let's check out putting 0 in there. So let me come in here with an eraser. And don't try not to get overwhelmed. It's going to take some getting used to, but it's really good thinking, right? You can say to yourself, I will never use this. You will have to think. And so we want you to practice with thinking, right? And working through constraints and saying, well, what do I know? What can I do? It's awesome. Cosine of 1/2 times 0. 1/2 times 0 is 0. Cosine of 0 is 1. 2/3 plus 1 is 1 2/3. And that's exactly where we're at. 1 2/3. Right? And you can check other ones along the way. I'll respect your time as well. If you feel that anything needs clarification, you just let me know, and I'd be happy to clarify anything, just like I've done in the past, even in these videos, right? I can post other solutions. So then they're going to ask us, well, what does this one look like? Okay, so this can get a little bit tricky. So the question is this a sine or a cosine? Has it been shifted and stuff? How much has it been shifted? So let's take a look at all the answers. Notice all the answers have no period adjustment. That's good. That would have been hard. Has no period adjustment. They're all just either phase shifts or shifting up and down. This one is absolutely a phase shift. So as you look at this one, the phase shift ones are in place. So that's a possible answer, that's a possible answer, that's a possible answer, that's a possible answer. The bottom row is not a possible answer because those are moving things up and down. This is definitely moving something left and right. And so it's not our regular sine graph because that's not even a possibility for this. So the question is how did this get moved? Well, it looks like it got moved this. Let me go back to a pen. To me, it looks like it took the original function and moved it back a little bit. And so what would do that? What would take the original function and move it back? Okay, well, if it's going to be moved back, let's get rid of the ones that are not in play. This is moving forward. This is moving forward. So if I thought it was moving back and I moved it forward to see what it was, notice that this one is going to come right up here. That means it's a cosine. So I now know it's D. That's what you're going to do. Critical thinking and analysis in order to come up with something. That's how you want to view this. Please do not say, I'll never do this. I would use a graphing calculator. We need you to practice analytical skills because that's what we know you're going to do in a job or other things, is analyze and make decisions. So let's look at this guy. This guy has been shifted up. So the ones that are possibilities are this bottom row right here. Okay, now it's been shifted up how many units? Well, it looks like it's been shifted up 2 units. Well, they have all been shifted up 2 units, except not all of them. So which ones haven't been shifted up 2 units? Or which ones have been shifted up 2 units? This one and this one. Do you think it's sine or cosine? So if you bring this guy down, would it be sine or cosine? Let's bring it down 2 units. Right there is where that new top point's going to be. That's not going through 0, 0. That, my friends, is cosine. And we're G. And you can go through and do this with every single one, and it's awesome. Right? That's how I want you to think about it. This is the best. I do a lot of... I have these on the exam. At least historically I've had them on the exam. And they're really, really good. And much like this, where there's not a lot of, oh, I don't know which one. So what about this one? This one's been shifted up 2 units. So shifted up 2 units, those are our same guys. If you bring this guy down 2 units, it's going to go through 0, 0. This is E. Awesome. How about this guy? Shifted down 2 units. Well, those are the non-highlighted ones on the bottom. If you shifted it up 2 units, 1, 2, you would have it going through 1, 1. It's a cosine, so it is H. And you're going to just go through and complete the rest of them. This one is looks like the regular cosine graph, right? There's no real change in that, but that's weird because the regular cosine graph isn't there. So which one could it be? Well, let's take a look. It would definitely have to be a phase shift. It wasn't shifted up and down. So I'd be looking at this one or this one or this one or this one. Well, it's not going to be a cosine graph, I don't think, because if I were to shift it, it's now going to go through 0, 0. So it's going to be one of the sine ones, and it's shifted pi over 2. And so which way would I need to shift this guy? The original sine function, let's look at the original sine function, looks like this, right? It goes up from there. So I would be shifting it back. I'm looking for something that's being shifted back those units. That would be A. I'm sorry, not A, B. B would be shifting it back, right? A is shifting it forward. So it's B coming through. And then for similar arguments, this would be A. It's the exact same shifting. This time I would think about it needing to be shifted forward in order to go through the 0, 0. And if it goes through that, if I shift it forward, then that's going to be A. And then what's this guy? It's got to be a cosine. If I shifted it back by pi over 2, it would look the same. So it looks like it's a cosine shifted back. That's C. Right? Because remember what the original cosine function looks like. It looks like this. And so this one was, they took this graph and let's look at C. They moved it forward pi over 2, right? I'd have to move it back to get the original one, so that means it meant move forward. I might not have explained that well in the very beginning. And then this one is F. This one shifted down 2 units. It's definitely a sine function. And if we go to F, that's a sine function shifted down 2 units. So good problems there. So now we'll move forward to section 7.